enjoy with our first day. Yesterday, we talked about the application and the introduction for directional drilling and discuss many features of the directional drilling and many types of directional well profiles as type 1, type 2, type 3 with the building, holding the angle, and deviating the well bore to the desired direction. Today is more important lessons and significant lessons for the directional drilling, which is the deflection tools. Deflection tools is the tools that make the well path, is the tool that is responsible for direction of the well to start the kick-off point, then building the angle, then holding the angle, then dropping the angle to the target. So how we can do this plan or trajectory is through deflection tools. We have the deflection tools is classified as a bottom hole assembly. It's a bottom hole assembly that any directional drilling should have that have many options according to the applications, according to the cost, according to the budget available to use mud motor. The first type of the deflection tools is mud motor or turbines with bent sub or housing, whipstock, jetting control or jet bit, power drive, or stabilizer controlling. We will start to discuss each element in details. First, as mentioned, the deflection tools, first or the earlier method for deflecting the well and starting the kick-off point. As we mentioned yesterday, the kick-off point is the starting point of the well at which the angle will start to building angle or to deviate from the vertical. First technique in the old is using whipstock or wedges to deviate the well. First of all, we install the whipstock or the wedges each, then we install inside it the directional bottom hole assembly. Then it will make the deviations and starting the building. This is one of the oldest technique. The drillers applies weight on the whipstock to drill about 10 to 15 foot. Then another trip is required to make the full gauge. Full gauges mean make the hole in the size on the same size of the hole. After drilling this section, some surveying meaning make a measurements of the inclination of the azimuth and cause the requiring building section for the well to be completing. The directional wedge techniques is time consuming and it is oldest techniques and have limited application and requires many operations to start the kick-off point. So it is seldom used or it is not used in anymore, but it can be used for specific applications. If we want to drill inside the casing, we make whipstock casing to drill inside the casing as a casing window. Then we start to drill with other techniques or other tools. Another techniques is jet bits with oriented nozzles. The jet bits is an ordinary bit, but have large nozzle, one large nozzle that the drilling fluid will start to circulating from this big one and directed to the desired direction. When we starting to circulating the mud and pumping the drilling fluid, it take the desired direction as we want in the plan. This technique of getting nozzle, can be effective at initiating the deflection only for very soft formation. It cannot be run for hard formation or soft medium formation. It will be difficult. The bed is lowered to the bottom. The operation is starting with the bed is lowered in the bottom. The jet or the high or the greater or larger nozzle is oriented in the desired direction. Then the mud starting to flow and initiating with no drill string rotation. The drill string will be fixed without any rotation. Only the drilling fluid will be pumping through the large nozzle. After drilling fluid has been pumped about 3 feet, we drill. Then the driller initiate to conventional rotary drilling. That's mean to rotate all the drill string. Then after this process is then repeated. Hole surveys, or what is the meaning of hole surveys, which is, as we mentioned yesterday, to measure the features of directional well. As we should measure true vertical depths, measure depths, inclination, and azimuth. The third techniques, which is most common used today for small economics, is called downhole motors. Downhole motors make a great advancement in the directional drilling because it's flexible, can be controlled, and can be attained the desired direction than the oldest two techniques, than the jet bit and web stock. Downhole motors designed to turn the bit, but the limitation of downhole motors, it's only make the rotation for the drill bits without rotation of the drill string. That cause many problems, that can be cause sticking, can cause problems in hole cleaning or carrying the cuttings. It's only allow the drill bits to rotate, and it's possible to orient the bit in desired direction and maintain the direction. The rig powers, the most advantages of this techniques, it's reduce the rig powers and reduce the wear or friction on the equipments. Downhole motors, we have two basic types of downhole motors. The first type is positive displacement motors, which we called it BDM, which is abbreviation for positive displacement motor, and turbine motors. All the positive displacement motors being commercially and used in many tools in drilling. It's composed from basically two elements, rotor and stator. The rotor and the stator, rotor is about an tube or pipe that rotate as the fluid enter the space between the rotor and the stator. The rotor and the stator have a chamber between them that separate them and allow the fluid to enter inside the stator and allow the rotation. As we see in this figure, the rotor is the solid one. It's called the rotor. It is the solid one. This is pipe. This is rotor. The stator is outside. So the drilling fluid enter, or the drilling fluid or the mud enter between the rotor and the stator and allow the rotation of the stator that drive the power for rotating the bit, the drill bits. The positive displacement motor composed of 4 sections. The first section is dump valve. The functions of the dump valve or the valve is to maintaining the drilling fluid out from the downhole motor when there is no circulation, to prevent the failure of the mud motor. The second section is composed is called power section. It's composed from the motor, rotor, and stator. The third section is the surface adjustable bent housing. So if the surface adjustable bent housing, it is designed to make the building of the angle. For example, if I want the build-up rate to be 1.5, I will be adjust this section to be 1.5 degree then each 100 feet I increase the angle by 1.5. But this techniques have many limitations because at each time I want to change the inclination or change or increasing the inclination, I should bring all the equipment out and then adjust the surface adjustable pump to increase the building angle, or if I want to drop the angle, I should make the drill string or to make a trip out from the hole and then adjust the bent housing to the desired drop off rate or building up rate. The last section is bearing section, is to allow the rotation of the mud motors and allow the rotation of the drill bits and stabilizer to keep the hole engaged. As we mentioned, there is 4 section dump valve, as allow the fluid circulation when the pressure below a certain threshold, which means when there is no circulation, that the fluid can be leaked off from the motor, and when there is circulation, the drilling fluid will enter the motor to allow the rotation. The second section is the power section that is composed from rotor and stator. The third section is the surface adjustable bent housing. That the surface adjustable bent housing that adjusted to make the desired direction or desired building angle or dropping angle. The fourth section is the bearing section. There is 2 types of the bearing section: thrust and radial bearing section. Thrust bearing sections that allow to be withstand with the loads, with the vertical loads and radial loads that result from the drilling operation, and protect the mud motor from failure according to any issues or any failure and loads that subjected during drilling. The main advantages of positive displacement motor is can be used to drill with soft or medium and hard rock formation. As we mentioned before, as in the last types, the jet bit cannot be used in medium or hard formation. It's only used for soft formation. With positive displacement motor, it can be used to drill soft, medium, hard formation. It can be used also with any rock types. Can be used with any rock beds, with any as poly BDM or BDC, or can be used with roller cone. Any types of rock beds can be used with positive displacement motor. Most of surface pump also can be used with no limitation of specific pump required. Normal surface pump system can be used as conventional drilling to operate the downhole motors. Can be operated with aerated mud, can be used with air mud. Can be operated with air mud, foam, or any types of mud, oil-based mud, water-based mud. The main disadvantage of positive displacement mud is the elastometer of the stator can be damaged by high temperature and some hydrocarbon. So the stator, as we mentioned in the power section, there is a stator and rotor. This stator cannot stand with high temperature. So in high pressure, high temperature wells, I cannot use positive displacement motor for drilling because it may fail. The positive displacement motor also have another disadvantages. Is the positive displacement motor, it's allowed to rotate the drill bits only. It's not allowed to allow drill string to rotate, which is was its huge problem and may cause many hole problems for hole cleaning reasons, as the drill string not rotate, only there's the bit that rotate, because if we rotate all the drill string, we cannot make the desired direction. So in positive displacement motor, only the drill bits rotate. So it is disadvantages of the positive displacement motor. The design of positive displacement motor is composed from 2 helical gears. The solid one is the rotor. The one is the stator. The another one is the stator, and it's used to allow the power section to make the section for the rotation of the drill string. The internal element is said to have all threads and or teeth, and contact with the external element is this stator. This is the cross section of helical elements that consist of coupled profile that's achieved by gear design with a different diameter that allow the stator and rotor to be identical and meet in common center. This is this is a figure show how the rotor is moving during the rotation, as the rotor here is on the top side of the cavity. Then rotor turned to 90 degree and located in stator axis. Then if we drilling more, the rotor turned to 180 degrees located below. So according to the angle of turning angle of the rotor, it's define its location where it is turned and the cycle that allow the rotation. The positive displacement motor have performance. Each positive displacement motor, when I select the required positive displacement motor to drill my well or in the field, I should have to know the required horsepower. The required horsepower, each motor is classified according to the maximum horsepower that can be provided. The horsepower is calculated from the pressure drop required for the hydraulic and the flow rate and the efficiency of the system. The motor efficiency taken into account as the leakage of the fluid that can be happen when it's contact between the rotor and the stator, and many frictions factor that happen during drilling. Also, the mud motor is classified according to the torque. So if I should know the horsepower, the torque required. For in this example, the rotor and the stator come in many configuration. So this is configuration have here only one rotor and one stator. This configuration 1, 2, 3, 4. Four rotor, and this is 4 rotor that increasing. As I increase the rotor, it will increase the torque here 1, 2, 3, 4, 5, 6. So as I increase the number of rotor, increase torque. When I increase the number of stator, it's increased the RPM. If I want the rotation or revolution per minute to be increased, I should increase the decrease the number. I should decrease the number of stator. If I want to increase the torque, I should increase the number of rotor. So according to the application, according to your case, if I want to more hole cleaning, I should increase the RPM. If the hole cleaning is not significant problem and I want to make more power to the bed, so I increase the rotor. So according to your situation and your design, I will have a graph like that to show the performance of the positive displacement motor, to know how's the horsepower, to know the torque of the motor, and to know the maximum or the maximum horsepower that provided to allow the rotation for the bed. This is one with 5-6 loops with the rate of 400 gallons per minute. If I change the diameter to 6 inch instead of to increase the diameter at 6 inch, it will result in more another performance. As we see in this picture, this is 1, 2. It is the number of rotor, one rotor with 2 stator in the line, in this line. As increase the number of rotor and the stator, if I increase the number of rotor, it will increase the torque. If I decrease the number of stator, it will increase the RPM. So according to the application, according to your case, according to the required or desired application, it will select the best motor and best configuration of the positive displacement motors. This is the first one of the downhole motor. Downhole motor have positive displacement motor, and another techniques it was used, it is the turbine. Turbine have similar concept of the positive displacement motor, but it also have rotor and stator configuration, but with another configuration. Where rotation energy is providing by the flowing fluid, the same concept for the positive displacement motor to allow the rotation and provide the torque for the bed. It's composed from two sections. The turbine motor is composed only from two sections, turbine motor section and thrust bearing radial support bearing. The turbine motor section is provide the power, while the bearing section provide the protection and allow to drill and resist all the radial and vertical load. Turbine section have multi-stage. It's composed from multi-stages, composed about from 25 to 300 according to the required flow rate. As increasing the number of stages, it will increase the torque. As I increase the number of stator and number of multi-stages, it will increasing the torque. This is the picture. So the turbine, as I mentioned, it's composed from two sections. Turbine section, the upper one is turbine section, the lower one is the bearing section. Turbine sections, it's composed from the shaft and the turbine stages that provide all the needed power and needed rotations, while another one is the bent housing and the thrust bearing. This is allow the rotation and make the direction stable to resist all the load that I faced during the directional drilling. The drilling in the turbine motors, the drilling fluid, after passing through the turbine motor section, it is composed into two mini directions or a channel to enter the center of shaft through large opening. It's called the main shaft. The drill bit is attached to the lower end of the main shaft, and the weight on bit is transferred to downhole turbine motor housing via through thrust bearing. This bearing section provides the rotation and allow transferring of the weight on bit. The weight on bit is the weight required to drill through the hole. Then it is transferred to downhole turbine motor housing. In thrust bearing section, it's composed from radial support bearing section that provide a resistance or carrying load to ensure that the shaft protect the shaft from any loads and allow to balance the forces and maintain the motor from the failure during the drilling operation. The main advantages of turbine motors, it can be used for hard and extremely hard component of the rock, can be drilled with turbine motor using diamond or polycrystalline diamond beds. It's also give a higher rate of penetration, ROP, can be achieved since the rotation will be at higher speed than that can be used in the positive displacement motor. Also, it's allow the circulation of borehole regardless of motor horsepower or torque being produced by motor. It's allow the circulation. There is no limitation for the horsepower or torque that can be produced by the motor, opposite to the positive displacement motor. The main disadvantages of this system of the deflection tool is the bit speed will be very, very high. That's limit use of the roller rock bits. In positive displacement motor, I can use all the type of drill bits, roller cone bits, fixed cone bits, BDC bits, all the bits. But in turbine motors, I should have roller rock bits as the I shouldn't have roller rock bits, as it cannot be used with turbine motors because the turbine motors provide very, very high speed. Another disadvantages of turbine motors is significantly larger pump systems required, as the rotation will be very, very high. So I need a huge amount of drilling fluid to be circulated. So the pump capacity and the horsepower of the pump is required a large pump to withstand with this high velocity. The third disadvantages is that unless MWD measure instrument is used, there is no way to ascertain whether the turbine motor is operating efficiently, since the rotation and the speed to torque cannot be measured using normal surface data. It's required another sophisticated system to monitor the data of the rotation and the torque for the normal surface data. Long power section to obtain the needed power to drill.